Hey everyone, welcome to my Intro to Physics episode number 3. Today is going to be about comparing the mass of two rocks to find a radius. Let's jump into reading the question. Two spheres are cut from a rock. One rock has a radius of 17.22 millimeters, and the mass of the other rock is 4 times greater than the first rock. So find the radius of this other rock. The question refers to two spheres, so let's draw one sphere, sphere looking, I'm not an artist here, and draw another bigger sphere and label both of those with their radius. One with a radius of 17.22 millimeters, and the other radius is what we are looking for, what we need to solve for. With the help of the picture, we need to try and find out how to relate our radius to our mass that are both given in the question. First, see if you can think of any relationships between equations between our radius and mass. For spheres, we know radius can be used for volume and surface area, and we should realize that surface area isn't helpful for any physics equations we know yet. With volume, we do know one physics equation that uses volume. The density equation uses mass over volume. And look, it has our volume and it also has our mass too. The density formula looks like the equation needed to solve our problem here. We can plug in the equation for volume to relate our radius and mass. Let's review the units of density, which is kilograms over meters cubed. Now that we have our equation to try, let's see what variables we have and will need. We have two rocks, so the radius of rock sub 1 is given at 17.22 millimeters. The radius of rock sub 2 is the other rock we need to find the radius for. And we just know that the mass is 4 times greater than the mass of the rock sub 1. Setting these equations equal to each other can determine the radius for rock sub 2. Easing into the calculations, rewrite our density formula here and start to solve for our mass, the variable we want to compare, or set equal. So with rearranging, we get mass equals our rho times our volume. We have two different masses, so let's mark this one just mass sub 1. The density is the same since it's the same rock, but they have different volumes as well, so let's mark volume sub 1 there too. For the other equation, the mass is 4 times more, so we have 4 times mass equals rho times volume. This is our other rock, so mark the mass as sub 2 and the volume sub 2 as well. Now to set them equal, we need to solve for just the mass, for mass sub 2. So we divide by 4 on both sides and then end up with sub mass 2 equaling rho times the volume sub 2, all divided by 4. Now let's set the masses equal. So we have mass sub 1 on the left, which equals rho times volume sub 1, and then we have mass sub 2 equaling on the right side, which is rho times volume sub 2 divided by 4. Now let's plug in for the volume equations, which will give us rho times 4/3 times pi times radius sub 1 cubed equals rho times 4/3 times pi times radius sub 2 cubed, all divided by 4. Now we can just go ahead and cancel all like terms on both sides, crossing out rho, our 4/3, and our pi. The equation that's left is radius sub 1 cubed equals radius sub 2 cubed divided by 4. Now we multiply by both sides again and cancel the 4 on the right. What's left is radius sub 2 cubed equals 4 times radius 1 cubed. Be careful there, flip that. We need just radius sub 2, so let's go ahead and cube root both sides now, and both radius go to a power of 1 now. So our final equation is now radius sub 2 equals cube root of 4 times the radius sub 1. Now plugging in for our radius for radius sub 1, we'll get radius sub 2 equals cube root of 4 times 17.22 millimeters. And this gives us our final answer of 27.335 millimeters. So after solving our relationship, we found that our rock sub 2 has a radius of 27.335 millimeters at 4 times the mass of just rock 1, with radius 7.22 millimeters. These kinds of really abstract relationships are really important for physics and may eventually be doing questions that are at that deal with two different questions or maybe even more that have a relationship to solve for. I hope these intro problems are as helpful for you as they are for me. Thanks so much for watching. Hope you come back to learn more exciting materials, and see you next time.